Here we're going to look at the second part of our cost behavior PowerPoint, and this part will deal with mixed cost and how do we divide them out using a simple method known as the high-low method. So to recap from the previous PowerPoint video, a mixed cost has parts of a variable cost and parts of a fixed cost. Over one range of activity, the total mixed cost may remain the same. Over a different range of activity, the mixed cost may change in proportion to changes in level of activity. In other words, sometimes it acts like a fixed cost and sometimes it acts like a variable cost. In fact, sometimes these mixed costs are called semi-variable or semi-fixed costs. Let's take a look at an example and we'll go through this step by step. Simpson Inc. Manufactures sales using rented equipment. The rental charges are $15,000 a year. So that's a flat amount, no matter how much we use it. So that's a fixed cost. Plus, they owe $1 for each machine hour used over 10,000 hours. So that's a variable cost. Once we hit that 10,000 hours, every hour past that, we have to pay $1 for each machine hour. So here we're shown on a graph. The fixed part is the $15,000. It's flat, straight across, until we hit the 10,000 hours. And then after that, the line starts going up $1 per hour for each machine hour we use above the 10,000. So that's the variable part. Now we need to separate these into a variable section and a fixed section for various things that management is going to need to be able to do, such as budgeting. And we generally, these days, would use Excel or some statistical software, which would be much more accurate. But when you need a quick and dirty, just want to know a ballpark, then, and that often happens, then a lot of times this high-low method can give you that. It's very simple, and so it is still utilized. Okay, and this high-low method separates out the mixed costs into their fixed and variable components. All right, so here we have an example. And we have 5 different months, June through October. We've calculated out our actual costs that we had to spend those 5 months and our actual production or activity for those 5 months. Now, we need to find what is the highest month of activity and the lowest month of activity, and we're going to use those, the highest and the lowest, to calculate out this formula here, and that gives us the variable cost per unit. That'll give us the variable part of our equation. So we need the difference in the total cost. In other words, we need the cost from the highest minus the cost from the lowest, and that's going to go on our numerator. Then we need the difference in production. So we need the activity from the highest month minus the activity from the lowest month. Okay, so here we've gone through and we've chosen the highest and the lowest. So August had 2,100 units, so that's the highest production. We're not looking at the highest and lowest cost, although they typically will also be. But we're mainly looking at the activity, the highest and lowest activity. So August had the highest activity and October had the lowest activity at 750 units. So those are the two that we're going to use. Then we're going to fill in the formula. So we need the numerator is the difference in total cost. So that's going to be the highest cost minus the lowest cost. So that's going to be 20,250 is our numerator. Okay, now we're going to do the denominator, which is the difference in production. So now the highest production is 2,100 minus the lowest production of 750 is 1,350, and that's now going to go in the denominator. So now for our variable cost per unit, we have 20,250 divided by 1,350. And that equals $15 per unit. Okay, so that's going to become part of our total cost equation. Our total costs equal our variable costs plus our fixed costs. So our variable costs are going to be $15 per unit times however many units we estimate that we're going to have. Okay, and so here's that total cost, okay, and this total cost is the variable part, which is the variable cost per unit, which is the $15, times how many units of production, okay, so that will give us the total variable for that period, and then we're going to add on the total fixed cost, okay. Now, right now, we don't know what the fixed cost is, so that's our next step. We need to figure out the fixed cost. Okay, so to do this, we're going to choose either the highest or the lowest and plug those in. So for the highest, we know that our total cost is $61,500. So we plug that in for the total cost. And of course, we already calculated the $15. Now we also know the units for that highest month. That's going to be 2,100. So we have 15 times 2,100. And we know the total cost ends up being $61,500. So now I just have to multiply out the 15 times the 2,100, take that number and subtract it from the 61,500, and I will get the fixed cost. Okay, so the $15 times 2,100 is 31,500. Now I'm going to subtract that from each side of the equation, and I'll get the fixed cost, which is 30,000. 61,500 minus 31,500, 30,000. Now I know the variable cost and the fixed cost part, and I can use that to figure out, to estimate how much it will be if I estimate how many units I will have. Now, if we had chosen the lowest, we did the highest, but you could have also chosen the lowest. Both of those are used to calculate out the variable amount, so you could use either one, and you would still come out with the 30,000 for the fixed cost. All right, so here is an example that you can take your time and do. The manufacturing costs of Alex Industries for the first 3 months of the year provided below. January, February, and March, their total cost and their production. And we can see that we're first going to have to do the highest. The highest production is here, February, and then the lowest production is 1,000 units, which is January. Okay, so to calculate the variable cost per unit, we'll have 125,000 minus 80,000 on the numerator, and then 2,500 minus 1,000 on the denominator. That will give us our variable cost per unit. Then we're going to plug that into our formula along with, we'll choose either the highest, 125,000 for the total cost, or the lowest, 80,000 with their respective productions, and calculate out the total fixed costs. Okay, so here we have February's activity or cost minus January's cost, February's activity minus January's activity on the denominator. And once I calculate that all out, I get $30 per unit. That's my variable cost per unit. Then I can take the high, which is February, and that was a total cost of $125,000, and we take our $30 times our number of units for February, which was 2,500. Okay, subtract that total from the 125,000, I get $50,000. Here for January, I have 80,000 minus the 30 times 1,000. Okay, and I will get the same answer. Okay, I will end up with the same fixed cost answer. Okay, whether I use this highest or this lowest, I'm going to get $50,000 for my fixed cost. So I know my variable is $30 a unit, and I know my fixed is $50,000 flat. Now, if we said, oh, how much will the total cost be if we have 2,000 units produced? Okay, so now I would just take the $30 variable cost per unit times 2,000 estimated production, and that would be 60,000, and then I would add the fixed cost, which is 50,000. So I would have 60,000 for variable. I'd have 50,000 for fixed. 60,000 plus 50,000 is 110,000. Would be my total cost estimate if I were to have to